Okay, hey folks, Mark Locklear here with a screencast on chapter 14, and this is how to use transaction and locking. I think I'm just going to sort of walk you through the chapter and just say a few words there. Not really any coding we're going to do. I think it mostly makes sense, based on everything you've learned up to this point. It should. The idea here is basically we're trying to isolate transactions, right? And in fact, you can see the example, first example that they've got here in the book. This idea of grouping transactions together, ensuring that they have run appropriately, and then either committing them or rolling them back based on that. And so, a lot of this is, and you see this a lot in WordPress sites. This is sort of mission critical type applications. You're not probably not going to implement something like this on a blog site, let's say, right? It's just not, generally it's a single person who might be writing a blog post. Maybe you're in an organization where you've got more than one person who could potentially be updating a page, but generally it's just not mission critical. If someone, were to update the language on a website and another user from a group might have the page open at the same time, not such a big deal. However, obviously in finance, banking, any kind of financial transactions, stuff like this is critical, right? You either have to build a system such that only one process can access it at a given time, which is probably going to cause latency issues and things like that, or you have to implement things like this where you're actually building in transactional locking, row locking, things like that. So again, the example they use here is we've got three insert statements. Each one of these has to occur. Now, why would it sort of begs the question, well, why would an insert statement not work? Well, you just never know, right? There could be, again, you have to imagine this in the context of a sort of client-server relationship. A lot of the work we've been doing in fact, all the work we've been doing up to this point is just working inside the console when you're updating it there. So there's very low chance of a transaction failing for some reason in an environment like that. But think about a scenario where you've got an external client, and so think about a web application where you've got maybe a cell phone app. And I mean, again, think about whether it's eBay, Gmail, any of the, all of the sort of, major enterprise applications these days generally have a website or a web interface that you can log into. They've often have an app on your phone that you can log into. So people can be accessing information multiple ways, and any of those systems might fail at any time, right? The database, so again, imagine a scenario where the database is on the back end, it lives on a server. You have multiple clients from different locations, either accessing information via a website, via a mobile app, and they're making updates over to this web server. So even though over to this database server. So even though the database server is online and there's no issues there, an update could be made from somebody's phone or from a website, and that update might fail. So that's sort of, that's the kind of scenario we're looking at here, where, again, in this case, you've got three different insert statements that are happening into invoices, invoice, and then invoice line items. And if one of those fails for any reason, you want to back out or roll back the entire transaction. So that's the scenario here. So concurrency and locking, they've got a couple of examples here. So here, you all are not going to be able to see this. I actually did some experimenting with it. You would need two different MySQL users. You can't log in if you log in with the same MySQL user and try to mimic what they've done here. You're not going to see the when transaction B happens, you're not going to be able to see the update even after the commit happens on with transaction A, because again, you need two different users to actually be able to see this happen. But here's a scenario where you might lock a specific you might lock a specific transaction, and then until the commit actually happens, it's not going to show up in the rest of the database. So this is the kind of thing where you're from a concurrency standpoint, you're trying to ensure that all transactions take place and they're successful before they're actually committed. So then there's also this concept of save points, and the book gives you one example there. The idea there is we can actually roll back, rather than roll back an entire set of transactions. We're specifying various save points, and then we can roll back to a specific save point. So again, you're getting more granular with the point that you want to roll back to. And for instance, in this case, you've got 3 save points, before line item 2, before line item 1, before invoice, and then if you go up here and look, you can see you've got save points. You've got these various save points that are set along the way. So you can actually again roll back to a specific point. Again, a lot of this is somewhat out of scope for the work we're doing. The size of the database we've got and the amount of data we've got small. But again, imagine a scenario where either a true enterprise, generally the term you'll hear used as an enterprise application. So these, large amounts of data, dozens, if not hundreds of transactions happening, every minute, or, maybe even every second in some cases. So in situations like that, you really need to be super specific about when a transaction occurs, either rolling the entire thing back, or in this case, having specific save points that you would roll back to. So then there's this concept of concurrency, and I'm looking here on page 427, I think. And concurrency is defined as the ability of a system to support 2 or more transactions working with the same data at the same time, right? So again, this idea of multiple users, or I really shouldn't even be using the term users here, because it's really about the transactions that are going on. So multiple transactions happening at the same time on the same set of data. And they do a good job of explaining the 4 concurrency problems you can have. Again, I'm not going to go into detail on all these. You can read through these, and again, don't, this is pretty high level stuff. I've never, with all the work that I've done with databases over the years, I really haven't had to deal with any of this. Unless you go on to be a database administrator, you probably won't spend a lot of time thinking about these kinds of things, but just know that they're out there and they're issues that that database administrators are thinking about. So things like lost updates, that's the simplest one, where again, this is sort of a scenario I mentioned earlier, where 2 users or 2 transactions are accessing or updating the same amount of data, or the same data at the same time. So basically, the last update that happens is the one that's going to be saved. So again, just to use the example of just updating a page or some text on a website, if 2 users go and edit that page at the same time, one user makes a change, they save their data and leave the page, and then 1 second later, another user updates and saves data to the page. Then again, the last update that happens is going to take place. Now, they've actually, I've noticed the last few years, WordPress has implemented a feature where if 2 or more users are updating a WordPress page at the same time, so if someone already has that page open and then another person goes and views that page or edits that page, you'll see a message there that you'll see a message there that someone else has the page open. So that's at a sort of low level. That's an example of either, I guess, a lost update or a dirty read. Again, I won't go into detail on dirty reads, non-repeatable reads, and phantom reads, but you can read about those there. And then the last two things I'll talk about are locking rows and then deadlocks. Again, page 433 talks about using this for share feature. Essentially, that will lock a given row. So other transactions or users could read data from a given row, but they're not able to update it. So again, the idea is if you have a particular transaction you need to run, you want to make sure a particular row doesn't get updated by some other process, then you can use this for share word to actually lock that row until the transaction is finished. And then once the example they use here is they're locking this sales reps row where rep ID is 2, and then they've got an insert that happens, and then once the commit happens, then that row should be unlocked at that point. And then the last one they have here is deadlocks. This idea of deadlocks, the way the book describes it, occurs when neither of two transactions can be committed because each has a lock on a resource needed by another transaction. So you can almost think of it like like an infinite loop for database tables and transactions. Both have a table locked, but they're both waiting for another transaction to happen, which never actually takes place. So that's the idea of a deadlock. And then they've got a handful of things that you can do here to prevent those from happening. Things like keeping transactions short. You want to ideally compartmentalize these as much as possible. The longer or the more sophisticated and bigger a given transaction is, the more difficult it's going to be to maintain, the more chance you run into of having things like deadlocks and other issues like that. So keeping transactions short, and then also we looked at having the rollbacks, having save points and then rollbacks in place to help manage that too. So I think all those things will work together to take care of those things. All right, I think that's all I'm going to say about using transactions and locking. I think the homework's pretty straightforward too, so not going to talk about any of that. Just if you have any questions, just let me know. Thanks.